So today we will discuss about polar equation. Like this polar coordinates, we have studies about a position of a point along with two perpendicular axes, that is called x-axis or y-axis. We have studied about that in Cartesian form. Now here today we will discuss the position of a point along polar coordinate, means with polar coordinate means with a fixed point, position of a point with a fixed point and angular distance, angular direction with a fixed straight line. So in we have studied, suppose a point P is here. This coordinate is x and y in Cartesian form. So what is the meaning of this one? The perpendicular distance from this one, this is x and this is y. So this is perpendicular distance from this one and these two perpendicular axes. From this here to here, this value is x, and from this here is y. So perpendicular, so position of we find position of P with perpendicular axis in Cartesian form. But now, so in Cartesian form, we find a position of a point along two perpendicular axes, that is called x-axis and y-axis. Usually in Cartesian form, we find a position of a point along with two perpendicular axes, that is x and y-axis. But now in polar form, we find a position or location of a point with a fixed point, called polar origin, and this is the distance and angular direction with a fixed straight line called initial line. Suppose this is called initial line. So we have to find position of this one, P. P is a point in space, and this is the fixed point O. O is called pole. This is pole, fixed point O. So we need two things to find the position of the location of P. First, the distance of P from O. We need two things: distance of P from O, suppose this is R, so this is R, and the angular direction of P from this fixed straight line. This is called theta. So this is called theta. P equal to P, the coordinate of P is R theta. R is the distance from a fixed point, and theta is angular direction of fixed straight line, that is called initial line. Okay, so we need this one, and here we can the position of P, we can say here we can say position of P does not remains, the position of P does not remains unique. How we can see this? Can see here. Suppose this is position here. This is point of P. This is initial line. This is P 350 degree. This is 350 degree. This is position of this one. We can write this one same. This one we can say P 2 minus 45. This is minus 45. This is 45 in opposite direction. So this is minus 45. The same position. This and this is same. Or you can say this is 1 here is 350, 360, one round, and then the second round is this. So what is the angle of this one? One round is 360 and the 350 means 675. So this is position of P is 675. So the position or location. So the position of P 350 degree, P 2 minus 45 degree, P 675 degree are same. So in all cases the position of P is same. So we can say does not remains unique. Okay? It means the position of P r theta and P r theta plus n into 360 degree or P r theta minus n into 360 degree are same. So r theta or r theta plus minus n 360 degrees. So this is 350, 350. Okay. If we write here 315, put n is equal to 1 plus 1 into 360 means 675. 675. The position of this is 6. Okay. We put minus here. So this is 360 means 315 minus 1 into 360. This is minus 45. This is minus 45. So the position of all are same. So we can say the position does not remains here unique. Now here we see, suppose this is point here P 225 degree. Suppose this is, so this is 225 degree. This one and a point here it moves. Here this one, this is angle 45 degree. Suppose this is P. This is also 1. This is also 1. The distance between O and P is 1. Here this is O. Here also this is 1. So if it moves in opposite direction, here it is in this direction, the same distance P dash. This is 1. So this we can write this position and this position here. This is 350 here, 225. 225 means this one. This is 225. P 1 into 225. 180 plus 45. So this is 45. So P dash is minus 145. So the position of P are same. P 1 to 125 degree or minus 145 degree, because it moves in opposite direction. So R, generally R remains positive, but in some cases we can take R negative also. So we can say here P minus R theta and R theta minus R theta and R theta plus pi, plus minus theta plus pi have same position. This is R theta. If theta is here, suppose R is minus this one 1 and theta is 45. And theta is, if we put theta 45 plus this becomes this one, and if direction change, minus R here 1 R. So this is becomes 1, if 145 is this one, minus 145. So minus R theta and R theta plus pi have same position, same location. Okay. So this is very important thing. You have to understand all the things. The direction may be sometimes like this one is written and these two things are given, but the position are same. Okay. Now we find distance or polar distance between 2 points. Distance between 2 points. How we find distance between 2 points? Suppose in polar form, the point here is a point P. P is R theta, yeah, R or R alpha or R1 alpha. So that this is R1 and this is alpha. Okay, and the other point is Q. Q is R2 beta. Means this distance between O to Q is R2 and the angle this is beta. So what is the angle between P and Q? So this means P and Q. What is the angle? This is beta minus alpha. Okay. Position of P or coordinate of P is R1 alpha. This is R2 beta. So angle between P and Q is beta minus alpha. So now we PQ square. The formula of this one, between 2 points, distance between 2 points. In Cartesian form, distance between 2 points is x1 minus x2 whole square plus y1 minus y2 whole square. So PQ square equal to, what is OP square plus OQ square minus 2OP into OQ, and angle between 2 points means cos beta minus alpha. So what is the value of this one? OP square means R1 square plus R2 square to R1 R2 cos beta minus alpha. So this is the distance between 2 points in polar coordinates. Now we find area of triangle. Area of triangle. How we find area of a triangle? Suppose this is a triangle. A, B, C. Now we have to find. So the position we have to find two things: position and angular direction. So position here with a fixed point means distance between distance of A, B, C from a fixed point. So from fixed point, this is A distance, this is B, and this is from distance. So we can write, suppose this is R1 alpha, R2 beta, R3 gamma. Coordinates of A, B, C are R1 alpha, R2 beta, R3 gamma. Now this is R, means the direction, this is distance is R2 and this is beta. This is distance from O and A is R1 and this is alpha. So this is alpha minus beta. And the distance, this is R3. What is the angle of this one? Gamma. So what is this one? Gamma minus alpha. Gamma minus. What is this one? Total is this one and alpha is this one. So gamma minus alpha. Okay. What is the value of this one? From up to here, gamma minus beta. Up to here gamma and this we subtract beta. Now if what is the angle, the area of triangle, we see area of triangle, we know area of triangle where A coordinates are A, B, C and the sides are A, B, C. So area of triangle becomes like half AB sine C is equal to half BC sine A is equal to half AC sine B. So if sides are ABC and the angles are, this is angle A, this is angle B, this is angle C. So this area remains like this. But here we will find, from here we have to find area in polar coordinates. So same things. So area of now triangle ABC. ABC. This triangle is first this one minus this plus this. So we have to find for all BOC. Triangle BOC minus this one and this one. BOA minus AOC. So BOC R2 R3, like for this AB line, R2 R3, half R2 R3 sine angle. What is this angle? This angle is gamma minus beta. Gamma minus beta minus half BOA. This one R2 R1 R2 sine. What is this angle? This angle is alpha minus beta. Alpha minus half AOC. R1 R3 sine. What is this angle? This angle is gamma minus alpha. This angle is gamma minus alpha. Gamma. This is the area. Or if you make this positive, you can make positive by taking minus outside. Sine minus theta is minus sine theta. Or you can write like this one, half R2 R3 sine gamma minus beta plus half R1 R2 sine beta minus alpha plus half R1 R3 sine alpha minus gamma. So you can take, put this in both form. You can put here minus or you can put plus by taking minus outside. Okay. So this is the area of a triangle ABC. Now we find equation of a line. So polar equation of a line. Polar equation of a line. So we find polar equation of a line. Now so here in coordinate axis, how we find equation of a line? this is initial line, O is a fixed point and this is a line. And now P is a point. Suppose P r theta is a point on a line. P is a point on a line, then the coordinate of P is r theta. And now draw perpendicular. Suppose now we draw perpendicular from O, perpendicular on a line, perpendicular on line from O, which meets line at Q. Suppose here we draw perpendicular. This is perpendicular 90 degree. This meets here Q. This P alpha. The distance, this is P and this is alpha. This is total theta. So what is the angle? Theta minus alpha. The distance between O and P is R. Okay, this distance is R, this is P, this is 90 degree angle. Okay. So now we see this is right angle triangle. So PQ is a perpendicular, this is OQ is base and OP is hypotenuse. So now what is the value of this P upon R? P upon R, base upon hypotenuse is cos theta. So theta, what is theta? Angle between P and Q. What is the angle between P and Q? Theta minus alpha. We can say cos theta minus alpha. We can say P is equal to R cos theta. P is equal to R cos theta minus alpha is a polar equation of a line. Okay, straight line. P is equal to R cos theta minus. Now we have it has particular cases. We can say particular. Suppose this line, first is line passes from origin or O. Okay, origin or pole. This is passes from P. If this line passes from P, you can say like this one, you can make like this one, so angle becomes theta 1. This is O, or you can passes from here also, this line shift here. If we shift here, so the distance OP, this one, the distance between O and Q becomes 0. If it passes from origin, then P equal to, see, this P becomes 0. So equation of straight line becomes P equal to 0, means R cos theta minus alpha equal to 0. So R does not equal to 0. It means cos theta minus alpha equal to 0. Means 0 means cos plus minus pi. Means theta minus alpha is equal to plus minus. Theta is equal to alpha plus minus pi. This is theta 1. So this is theta 1. What is theta 1? Theta 1 is alpha plus minus pi by 2. If it is passes from origin. Okay. Now we take, if the line is perpendicular, to initial line, means this is like this one. This time this is this one, this becomes this one. This is suppose B, perpendicular. So this is angle here, P is this theta, total, this. So if it is perpendicular means this is right angle. So where is right angle? Right angle is this one. Right angle is this. Means this is G. So it means alpha equal to 0. If it is here in this direction. If suppose this is in that direction, suppose here, you can say this line, this is O and this is P in this direction. So here alpha, what is here? This is 0 and this is pi. So in this time alpha becomes pi. If it is the opposite direction, alpha becomes pi. So in this case, alpha equal to 0 or pi. If it is perpendicular to initial line, if it is perpendicular to initial line, alpha becomes 0 or, so the equation is p r cos theta minus alpha. The equation of line is this one. So alpha becomes 0 or pi. If it is 0, if alpha equal to 0, then p is equal to r cos theta. If alpha is equal to pi, p equal to r cos theta minus pi. If we take minus outside, cos minus theta is cos theta. You can say r cos pi minus theta. So pi minus theta is in second quadrant, cos second quadrant. Okay, this is pi minus theta here, second quadrant. In second quadrant, cos positive or negative? It is negative, so we can say p is equal to minus r cos theta. If it is pi, minus r cos theta. If it is 0, r cos theta. Now take third case. This line is parallel to initial line. If it is parallel to initial line, it means this line becomes, suppose this is this one, and the line was previously, in first line was like this one, then in second case it becomes like this one, in third case this becomes like this one, upside or maybe here also. So now this is p, this is theta, this becomes here, okay, this here 0, this becomes here. So theta or alpha, what is alpha here becomes, what is alpha? Alpha, this becomes q, this becomes q. So alpha is equal to pi by 2 or minus pi. If it is parallel like this one, so this becomes pi by 2. Now this, because this is 90 degree, this is 90 degree. So 90 degree angle makes q. Q makes 90 degree angle with initial line. So what is the value? What is the value of the line? P is equal to r cos theta minus alpha. If it is pi by 2, you can write alpha is equal to pi by 2. So r cos theta minus pi by 2, or r cos pi by 2 minus theta. Cos minus theta, cos theta. Pi minus theta in first quadrant. First quadrant all remains positive, or cos changes into sin. So this becomes r sin theta. P equal to r sin theta. If theta is equal to pi by 2. Alpha. If alpha is equal to minus pi by 2, then P equal to r cos theta minus, means minus plus pi by 2. So you can write pi by 2 plus theta in second quadrant. First, if it is pi by 2 plus minus theta, cos changes into sin. First you write r sin theta. In second quadrant, we see this one and sine of this one, not cosine. We see sine of cos. In second quadrant, pi by 2 plus theta. It is in second quadrant. Second quadrant, cos remains negative, so this becomes negative. P is equal to minus r sine. So this is the equation of the line. Here the conditions are three. First equation of line, P is equal to r cos theta minus alpha. If it is passes from origin, then P becomes 0. If it is passes from other, here parallel perpendicular to initial line or parallel to initial lines, so it depends, the equation of lines changes according to condition. What condition is parallel, perpendicular, or making any angle. So this is very important. So we have to find location of a point in the polar coordinate, and then same thing we will discuss more in next